Hey guys, Vasily here, AI architect with cnvrg. In this video, I'm going to walk you through serving and building inferencing on top of your models that you can deploy as an endpoint or as a service, and how you can introduce inferencing into your pipelines. I'm going to be here in the MNIST project. If you have your cnvrg.io interface open, you want to walk along with me. We're going to go ahead and head over to the serving section. Here we can see I have an endpoint running. Creating a new endpoint is pretty simple. You just hit create endpoint, and this is where you get to select what type of endpoint. This is going to really cover all of the different designs and architecture patterns that you would have in a typical enterprise. You can choose to go with something like TensorFlow serving to optimize on TensorFlow models. You can do batch inferencing, so if you already have a large data set that's already been deployed in your organization, already curated, and you want to now deploy your model onto that data set as a batch, so you can do inferencing on the entire data set and potentially, enrich it or try to understand create new features. That would be a great option there. Web service is just what it sounds like. It's going to wrap your model in an API, give you an endpoint that you can actually then post data to or files to, and that will then allow you to perform inferencing on each event that hits that API. And Stream is very similar to having a web service. However, what makes it really unique and useful, Stream applies on Kafka topics. And so you can now take advantage of Lambda and Kappa architectures to decouple your streaming flow from your inferencing and introduce AI and ML experiences into your real-time data pipeline seamlessly, all from within cnvrg, by selecting the Stream endpoint. And that then allows you to select a input topic, and for each event that hits that input topic, you'll perform inferencing on that event. And then you specify an output topic. And in that output topic, you can output anything you like from your predict script. And so that allows you to then output a feature vector, a prediction, just a plain text, a file, whatever you like. And so that is very useful for real time and not having to necessarily create post requests, just redirecting streams of data into Kafka and allowing the inferencing to take place. I'll go ahead and select web service for this particular video, but we'll have other videos to go over the other specific endpoints and kind of go through and walk through a little bit of the subtle nuances and differences between the two. So in this demo, we'll go ahead and give it a title. So for this endpoint, it's the MNIST data set that we've trained on, and so we will then do digit prediction. And we'll just go ahead and call this one demo. So this is our digit predict demo. We can give it any amount of compute, select any image we like. And you can also, as you're deploying these endpoints, in this case, I'm just doing a demo, basically just a testing environment. Nothing too robust required here. However, if this was going into production, you could just as easily deploy into dev, stage, or production from a single cnvrg by simply selecting a template that is pointing to your production instance and giving it a lot more resources. So say I want to use a robust Intel optimized Cascade Lake architecture, and I want to go with the bare metal, or I want to go with an optimized Intel Cascade Lake in the cloud. I could select that at this point and spin up my inferencing on that environment. Now for prediction, we know that we simply need to provide a prediction file that handles the actual inference logic. Now this file is very basic. It can have any logic you like in it, as well as just like with experiments, if you've seen that video, you can introduce your own print commands, and you can also import cnvrg and use the cnvrg SDK to actually log metrics. And all you need to now specify is the function inside of your predict script that needs to that will actually get the data passed to it, and that returns some result. And that result can be anything you like. You can also select a pre-processing script and a function as well. And you can also select a particular commit version. So with the commit version, that's just basically a version of the file system, a commit that you want that file to be pulled from and deployed, so that you can always deploy from your last known QA assured deployment, or your best model. That then ensures that you're getting the best weights as well, because the commit you select is going to determine which weights file is going to be chosen for the endpoint deployment. And not to worry, you can always update, as you'll see in the configs. And because we're doing the MNIST example, we're going to go ahead and say that we want to accept a file as input here. That will then allow us to send JPEG files of handwritten digits to this endpoint. And when we send that file, the entire file will then be passed to our predict function, which will handle the logic of actually taking it and passing it to our model.predict call, and then returning the actual predicted digit result to us. So now we've configured everything for our web service, and we can deploy our endpoint. So you can see here, once you've made all of your selections, Converge will now go ahead and allocate the compute that you selected. It'll actually then go ahead and give the endpoint the title that you selected as well, and then go ahead and pull that Converge image that we chose. So we went with just the stock Converge CPU image. It initializes that environment, launches the container itself, and makes available a public IP address. So this endpoint is running now on this is still an internal IP. It'll actually then get routed through a load balancer if you have chosen to configure your Converge that way. Or you'll have to be connected to the VPN or on the internal network to use this endpoint. So we support all sorts of deployment models and strategies that way. Converge will then go ahead and, based on anything that's in your requirements.txt file in your files directory here, it will go ahead and then install any additional Python dependencies that you may have specified. And this is also where your prerun.sh file will be executed. And so that will then go through and validate that everything's been installed and deployed properly. Once it actually deploys and successfully becomes an endpoint, you'll be routed to the next screen. Well, let's see here. We got an error because SciPy was not in our requirements.txt. So there you go. So if you did not, as I did not, select the right commit version for your deployment, then you may have made changes into your development environment, and those changes will affect how your deployment functions. And so if I come over to my files section here, we can then navigate down to where our requirements are, and we can also see our predict file that we chose. So now looking at our predict file, we see that we ask for the SciPy utility for imread and imresize, and that's how we're doing our prediction. Also, I mentioned that log metrics. Here's where we're logging those metrics. So now basically that was the one import that we were told does not exist. So if we want to validate that, we can see in this particular commit version that we selected, what are we pulling in? Okay. So because we modified the imports a bit for a different deployment, we caused an error. So we can now create an edit. We can re-add our imports. and then we can give it a title for that commit message. And that creates a new commit with our new changes. Now, the old commit is still there, so if somebody else was dependent on those other imports, which probably one of my colleagues or even I were depending on it for a different script or different deployment, those are still available in that commit. So it doesn't break any other dependencies, it doesn't stop other processes from running. We just simply made some changes that are going to allow what we are trying to deploy currently to run. And so we see that we're stuck in the error stage here. It leaves our endpoint up and running so that we can always come back and check those logs if we had additional errors that we needed to troubleshoot. And then if I come over here, there's an option to start the endpoint or to rerun it. And so I'm going to go ahead and choose rerun. And now it automatically, since I have a predict demo deployment that's in the environment, it appends a digit there for it to be unique. And here, instead of rerunning on that commit, I can find that predict digit demo commit that I just created, which has the requirements.txt file that I require for this deployment. Everything else staying the same, we can deploy this new endpoint, and we can see that it's initializing. So now, as it initializes, it'll actually now go through and perform the same operations that it performed before. In this case, however, it will actually be pulling from the latest commit that we just specified. And so if we watch closely here, it'll actually now, when it runs that requirements.txt for the pip install, it'll be able to actually bring in all of the dependencies we require specifically for this deployment. And that will then generate a different result. So while that's running, we can go back to serving here, and we can get rid of our failed attempt to clean that up. And this doesn't have any effect on any existing deployments that you already have up and running. These are operating off of their own commit and their own static version. So the changes that we're making and the deployments that we're performing here have no effect on anything else that's running in production. So now we see that our script is running, our requirements are being checked for if they're satisfied, and then here we go. The requirements.txt is picking up, and as we can see, we're going to start actually having our SciPy installed here. So now we shouldn't have any dependency conflicts with this deployment. And so that's how you also troubleshoot your deployments and ensure that you're operating on the right commit versions. This makes it very easy for you to now tie this commit to this particular model and this particular deployment, and you can standardize as you move forward on that paradigm. Now, because we're adding a few more packages, it just takes a little bit longer in this case to start the endpoint. But now we have all of our requirements installed, Python has been validated, and the server has started. And so now we have a fully running endpoint. So if we check the config here, we have our version 1 of our model has been deployed, 100% traffic uptime, and here's all of the settings that we did configure. You can choose to set up continual learning at this stage, where you can track tags inside of your endpoint for things like model drift. And once a certain threshold has been met, you can trigger an email, or you can trigger a flow to run that will then retrain that entire pipeline and redeploy this endpoint proactively without you having to do anything. And so if you don't know how flows operate or what those are, we do have another video on flows. I recommend you watch that, and that's how you can then automate the deployment of these endpoints and standardize how that flow works to avoid any manual process. This also gives you access now in the endpoints to logs, to Grafana for actually looking at the CPU, GPU, memory, all of the metrics around the endpoint itself. You can look at the activity, which is the log of the actual server that's running for you, the config that we were just in, as well as Kibana. And Kibana will load Elastic so that you can look at all of the logs, which are also available to you here. We haven't run any inferencing yet. So if we were going to run some inferencing, and I can I can actually jump over in my other screen here, and I can run some inferencing on this endpoint. And now, once we run some inferencing on the endpoint itself, basically that will then return results to us in our CLI commands. You can also you can use the curl commands here. You can also use the Python SDK as well. And basically, as you perform inferencing, then you will also see the charts that you've specified updating, and you will also see the let me see here. So let me run some of these for us. And you see here you have your API key, and I can simply now go find that, and you take that curl command, execute it from a terminal, which I'm doing on my other screen here, and I am getting predictions. And so as I see predictions showing up in my terminal here, I should also now see that refreshing here in the UI, and here we are. So I just sent 10 requests. I see my latency logged for that particular model. And then since I also added a custom chart command, so I'm actually printing out a metric here for every digit I predict, I just go ahead and log that metric so it's visually available to me here. And then that's also available in the logs. So I can see for every single input, and we don't see the input here because we're sending files. We can go grab those files from the back end, but then we see the actual output for each of those predictions, things like elapsed time, and then that's all available for us in Grafana and everything else. And so I can also then choose to create a new version. This can be done through an automated process like the flow executing by selecting a different version of your model based on a commit, and you can then update to a new version, and this will actually then, while the update is in progress, continue to keep model 1 alive, so I can continue to support inferencing on that endpoint while I'm switching between models. And as model 2 is deployed, basically what happens is your endpoint stays up, and we deploy the new endpoint, whether that's a new prediction file, new weights, a new particular commit that has different weight files in it, or models that are going to be loaded. And then once model 2 is up, some checks will run. If there's any issue with your new model, Converge will automatically stop and roll back that endpoint so that you can actually continue to have uptime on your previously working model. If nothing's wrong, Converge will then go ahead and switch to model 2 and deactivate model 1, and then that will save model 1 as a version in your history, so you can always stop and roll back at any given time, manually or through the CLI. And so all of those versions will then be available for you here. You can also choose to have scalability for high availability. You can choose the number of pods that you want to scale up to in the event that you have high throughput. And then that will automatically then handle situations where traffic has a spike and where you need to dynamically allocate additional resources to be able to handle that. And so with all of that, you can now monitor your endpoints. You can enable continual learning to trigger additional training events to redeploy models proactively. You can have a great degree of control and visibility into the logs that are happening behind the scene. You have inferencing logic, and then also, as we saw, you have charts available for you as well. And so those charts will always be updating as you get additional requests and as traffic starts to increase once your model is live as an endpoint. And the other thing is you can track its progress as well from the top level here and from the dashboard. If you've seen that video on using the dashboard, you can actually see the utilization and allocation for your endpoints from that screen. And so when now that our model should be finished deploying here, we have model 2 live and running. We see here we've got model 1 metrics still on the charts. I can go ahead and run some inferencing on model 2. Do that over here in my terminal, and here we are. So now the new version that we've deployed has seen some requests come in, and we can see that we still have access to our model 1 metrics, but now because we have model 2 deployed, we also are tracking model 2 as a parameter here. So we can see now anything that we sent to model 2 that's been inferenced is going to be tracked differently than the inferencing we were doing previously on model 1. And so that concludes our end-to-end demonstration of endpoints, troubleshooting endpoints, and also monitoring those endpoints. Thanks for watching.